So for the matched pairs design, or the matched sample design, it's the same thing. What do we have? Let's summarize what we have for the hypotheses testing. So we can see that we've got three different scenarios which look very, very similar to the scenarios we've had before. And hopefully you're beginning to see that these scenarios are looking very similar. So can actually draw out this scenario. They're always going to have t critical values and be considered to be t distributions. And so this scenario here equals not equals t distribution. And this is going to lead to a two-tailed test, two critical values, one there and one there. Do not reject zone right here in the middle. This could be a do not reject H0 zone, do not reject H0. And then we've got the reject zones over here, reject H0 here, and reject along here. And what else do we have? What are the critical values going to be? Well, our critical values are going to be plus or minus, that's over here, minus t, the t, remember t distribution, t of alpha over 2, it's alpha over 2 because it's 2 tau, with the degrees of freedom for this one are n minus 1, so I can just put df or n minus 1, since we know what it is, and over here it's going to be plus t of alpha over 2 with n minus 1 degrees of freedom. Okay, you can just barely make that out, but there you go. And all three scenarios have the standardized test statistic looking like this with n minus 1 degrees of freedom. Let's just go back up there though. So that's that one. Let's look at the second scenarios. Just get rid of this one. So the second scenario again is going to be a t distribution, and it's going to be a one-tailed test with rejection to the right. The arrow is pointing over here to the right, so let's put in the critical value is going to be over here to the right, and the rejection zones over here. So reject H0 and green. Do not reject H0 over here. So consistent, isn't it, what we're doing? And the critical value. So the critical value is going to be t of alpha. It's only one tail, so it's just t of alpha with n minus 1 degrees of freedom. And finally, this last scenario down here is going to be a one-tailed test. Rejection to the left, so 0 in the middle, t distribution, rejection to the left hand side, so your critical value is going to be right there, and we're going to put reject H0 over here, and do not reject 0 to the right of this, so do not reject H0 along here. Test always done on H0. And the critical value is going to be to the left of 0, so it's going to be negative, and it's going to be t. All matched pairs are t, and it's going to be alpha because it's only one tail, and then degrees of freedom are n minus 1. And to use the critical value approach, we then have to work out the test statistic, and the test statistic is worked out using this formula in here. So d bar is analogous to x bar, mu of d, actually mu of d, we could have actually put that down, mu of d, that comes from H0 is whatever value's in there, we could have actually put d0 in there if we wanted, but mu of d is whatever value's in here, so perhaps we could have put d0 in there if we wanted actually, it wouldn't make any difference. Just do that now. In fact, what I'll do is I'll make another. I'll make a sheet for of summary tables for you, and for the p-value approach, you just use the p-value stays the same as what I've shown you before. So the p-value can either be one tail, two tail, and if it's 1 tau, you work out the p-value as is. If it's 2 tau, you multiply that answer by 2. But I'll give you a summary sheet for that as well.